I'm Mr. Loy, your friendly D&T teacher. We are in phase 3 of reopening of Singapore. This is March 2021. In fact, this is the 23rd of March. As you can see, I still wear the face mask, and the school bell has just rung for 4:30 p.m. What I'd like to show you is your performance task on membrane switch, soldering and circuitry. So I don't want to have this video to be too long. There are certain skills that you need to apply or learn and apply prior to actual soldering, okay, using the soldering iron, or for those hobbies at home, you can actually have this cordless battery powered, in this case is the dual heat, alright, battery operated soldering iron as well. Okay, so in schools you'll be using the one from the AC outlet, and it's very hot. Okay, so since there's no one else in this workshop, for you to hear my instructions clearly, I shall remove my face mask. Right, there are some things you need to prepare, and if you can, follow the link provided below for another project requiring knowledge and skills when you do soldering, such as thinning the wires. What do I mean by that? Watch that video. And also, how do you clean the soldering iron tip, which I actually will do it, for example, with emery cloth. Right? You also need wet sponge for you to clean the tip quickly. You can also have what we call the brush shavings here. Alright, you can also clean away the grime and dirt that is on the tip of the soldering iron as well. Okay, and some safety precautions. Now, in that other video, you also have me explaining why we use flux. So of course, I also use flux to clean the tip very quickly. Alright, and of course, when you do soldering, there are a lot of fumes, a lot of toxic oxide gases generated by the soldering iron. So you must ensure that the workshop is also, or the room that you use your soldering or do your soldering, is well ventilated. Now, to cut the story short, let's make it quick. This is your membrane switch circuit diagram, and it's pasted on a typical Vanguard sheet. So this thin black lines will be where you lay the copper track, and this is the conductive material, copper track. The other side is for you to remove the paper so that it exposes the sticky side of the track, so that you can lay it across. Okay, so so basically you're going to run it over here, and this is the fixed value resistor, 680 ohm. Coming down, you will need to have a gap here before you start laying the track again, so you do not place the track too close together. And it leads to your light emitting diode. This is the circuit symbol for light emitting diode, and it goes back to the other end of the track. Okay, now you will also be given the so-called membrane switch. So this is where you need to use your scissors or penknife to cut out the window here and lay just one short copper track here. So when you imagine there's a window cut out already, when you attach this window, which exposes the two copper track, and when you close this other vertical track, it creates something like a closed switch. So current from the power supply, which is in this case the 9-volt cell here, direct current, will actually run through and light up your LED. Okay, as explained in class, your 680 ohm fixed value resistor actually helps limit the amount of current flowing, so as to extend the lifespan of the LED. You don't want the LED to be super bright and it doesn't last long. Okay, so we are going to go straight into laying of the track. So the first step is to use the copper track provided. There are two ways of doing it. You can measure along the actual circuit. Alright, so let me just bring down a little bit so you can see, and I'm going to zoom in a little bit here. Okay, so you can see the first way is to measure each length and cut with your scissors. You can tear it with your hands, but try not to do so. Peel the paper behind the track like so, and make sure the copper track is stretched, and you just run it along the black line like so. Okay, so my next short track will be the vertical one here. So this is the first method. You measure the length, and then you use the scissors to cut the appropriate length, and you do it for every track along the circuit here. Now what about the second method? The second method is quite similar. So let me just lay the second track over. You just need to take note that you need to run the second track over the first track. Alright, there's an overlap here. Now the second method is you measure all the lengths that you need, you cut it out, okay? And then you start peeling the paper behind and you start pasting it. So I'm going to pause here and complete the copper track laying. Now for your information, I took about under 2 minutes to cut out the rest of the track and lay it nicely here. Alright, and I completed this part of the copper track laying on the main circuit. I have not done so for the strip over here. Take note how well you and how careful and how neat you lay the copper track counts, alright, in your assessment rubrics. So take note of that. Now for the membrane switch side, I've just laid this copper track. How do you cut out the square hole here or to form the window? If you have a pair of scissors, you can fold this part of the Vanguard sheet and you cut a little bit of the slit here, and that's where you can actually introduce the scissors blade in and do it carefully. Apply fairly controlled pressure in order to cut along the dotted line. If you have a penknife, you need a cutting mat. You just place this Vanguard sheet flat on the cutting mat and you use the penknife carefully. So just going to show you quickly how I cut out the window of the membrane switch, like so. Alright, there you have it. So when we place the membrane switch, you can actually use glue stick, you can use double-sided tape, paste it over like so. Alright, and when you close this part, the current from the 9-volt cell will flow across because of this copper track. The first component that you can actually place over the circuit diagram and solder is our 680 ohm fixed value resistor, and this is the resistor. It comes like this. So what you need to do is to remove the paper lining, because when it's mass produced, it runs rows and rows with this paper that holds each resistor in place. Alright, now there may be some stickiness around the ends of the resistor, and as you know, resistor has no polarity. The current will flow in either direction, so you don't have to be mindful which side to place your resistor. You can use a pair of cutters to cut away that sticky end like so, but when you cut, just make sure your metallic wire here does not fly into eyes. Okay, so just take note of that. And another way is to use sandpaper or emery cloth in this case, and just clean the ends, and you expose or remove the oxide or any grime or any dirt, alright, that is resting or forms on the ends of this resistor. Okay, the next thing is you do not use the entire length of the resistor. You can actually cut to the correct length where you want to solder. Alright, so do not cut too short. And how do you actually solder this? There are a number of ways. One of which is we use the pair of long nose pliers here, and we hold one end, because you do not want, you use your thumb and your index finger to hold at the end of the fixed value resistor when you solder, because heat travels through the resistor and you might have your finger and your thumb burn, and you only have a pair of hands, right? So you probably need a helping tool, all right, or someone to help hold for you when you solder one end of the fixed value resistor. Now another more convenient way is the use of masking tape. All right, so I'm going to do that. Of course, you don't have to cut very neatly, very nicely a strip of the masking tape. You can just tear, all right? Just a small strip, all right? This is enough. So what I do is I will make sure that I cut the length of the fixed value resistor to where I want, and carefully place one strip of the masking tape. Alright, you can paste it over the fixed value resistor, or you paste it over one end of it. I'm going to solder at this end first. We're going to use solder, alright, and you're going to use a soldering iron. Okay, so see how I do it. This video is best watched in full screen so you can see all of it. Alright, do not touch the tip of the soldering iron with your fingers, of course, it's very hot. Do not rest the soldering tip onto the conducting wire of the fixed value resistor too long, because heat will travel through and into your fixed value resistor. The heat might actually spoil your component. So about 2 seconds, when your soldering tip touches the wire of the fixed value resistor, you introduce the solder directly at the tip of the soldering iron. It will melt and it will just flow through. So this is actually considered a good solder joint. Alright, it should not be like a ball, a block sitting on the copper track. It should be like a very nice flow. Alright, so I can't show you at that angle, but I think from the front view you can actually see. Alright, just a flat piece of solder. And it's also good to cover with solder right at the end of the fixed value resistor. Okay, I'm going to do the same over here. Remove the masking tape. Alright, and place the tip of the soldering iron at the end of the fixed value resistor for about 2 seconds, and introduce the solder and remove the soldering iron. Alright, like so. So your fixed value resistor, the ends of the resistor must be covered by the solder. I'm going to move on to the 9-volt clip. This is your 9-volt clip. The red represents, both wires are the same, it's just that the color of the insulation, one is red and one is black, right? So for conventional means, red means where current will flow from the positive terminal of the power supply, okay, based on the conventional current flow. So in other words, I will be soldering like so over here, and the black one on top nearer the fixed value resistor. Now you notice that the exposed wires of both, the exposed ends of both wires are not that long, so you can use, alright, what we call a pair of cutters, and just nibble around the insulation. Don't close entirely and cut the wire away, and lightly hold the rubber insulation in place, and you can actually expose it. In this case, it's longer than the red wire now. Okay, I'm going to do the same for the red wire. Now, if you don't have a pair of pliers, you can also still use your scissors. Alright, just be careful. Alright, the scissors blade is maybe longer, and I have actually very easily removed and exposed a little bit longer length of the wire for the red wire, like so. Okay, so similarly, you're going to use the masking tape, place it over the red insulation, alright, so that the exposed wire is directly above the copper track, and you solder it and repeat the same process for the black wire. I'm going to pause here for now. Alright, so here you have it. The red wire is towards the bottom half of the circuit diagram. The black wire is soldered on the copper track nearer the fixed value resistor. So when we connect this to a 9-volt cell, based on conventional current flow, electricity or electric current will flow in the red wire up from this track along the copper track, and it will light up the LED if it's connected or soldered correctly, and provided you use your membrane switch and you close it, right, through the resistor and back to the power supply. So I'm going to introduce to you your light emitting diode. As explained in class, the LED has polarity, meaning in this case you can see there are two legs here. One is longer than the other. The longer leg is where you will connect it towards the positive terminal of the power supply, which means towards the red wire. The shorter leg here represents the negative of the component, and sometimes you can actually look at the base of your LED. This is the top of your LED where the light emits very brightly. At the base of the LED, you can see over here where the shorter leg is, there is a flat edge. Alright, this flat edge represents the minus sign, which is the negative terminal. So what you're going to do is you can actually bend with your fingers and your thumb, alright, a fairly long distance, like so, or the length like that, and then we can solder it directly like this. Okay, of course use the masking tape and hold it. However, you may be considering applying your performance task, which is this membrane switch circuit, onto your handphone holder project. So which means you don't want your LED to be directly soldered onto the circuit diagram like so. You may want to use a short length of the red and the black wire and connect and solder one end of each wire to your LED, and of course the other end will be to the copper track, so that you can decide where your LED will be placed, positioned, installed on your Gelotong handphone holder. So we shall do that. I'll pause here, and after that you will see that I've soldered this. Now likewise, to expose the wire, alright, you hold it, but don't cut all the way, alright, you just hold it at the cross point here, and you just pull the wire, alright, just wriggle, move a little bit. Don't hold the handle of your scissors too hard, because you might just cut it off accidentally. Alright, with a few coerced movement, you can expose the multi-strand wire. We use multi-strand because we can easily bend the wire, twist the wire around the ends of the LED leads or legs. Okay, single core one is good for you when you need it to plug into the breadboard for prototyping or testing. So I will pause the video here. Alright, I've actually thinned the ends of the multi-strand wire. If you want to know how I do thinning, check out my other video. The link is given in the description below. So you can see that my red wire is connected to the copper track where the other red wire is, and I have also soldered the end of the black wire. Okay, so what I need to do now is not to solder the LED directly on the copper track, but to twirl and twist the other end of the red wire to the longer leg of my LED. Right? So in this case, I don't have to bend my LED so much at a 90 degree. So I will just twist it like so, and I'm going to solder it permanently, the red wire end, to the longer leg of my LED, okay, which is the positive end. So I will pause here and I'll get back soon. Now I've soldered the red wire to the longer leg of the LED. You notice that I bring it closer, you may be able to see some spikes of the solder sticking out. So having spikes are not good for conductivity in circuitry. So what you can do is you use a pair of pliers to cut it off, or you remelt the solder here with your tip of your soldering iron. I'm going to show you how I solder the black wire end to the shorter leg, which is the negative pin or lead of the soldering iron, of the LED, sorry. So you just introduce the solder, run the tip of the soldering iron, and make sure that the solder fuses with the wire and the LED pin or leg. Do not rest the soldering tip of your soldering iron too long on the LED lead. So this is how your LED is soldered. Alright? Now next up, of course, is to test with the circuitry. Alright? Of course, I'm not going to fix this yet. However, there's something very important that we have all missed out. Remember, I asked you to lay the copper track one over the other. Of course, the second one will be on top of the first one, the third one on top of the second one, okay, like so. But it is actually one copper track, a second copper track sitting on top. And what sits on top of the first track here is actually the sticky side of your second copper track. So there's no connection yet. So how do I ensure there's connection at, for example, this corner, that corner, this one, this one, this one, as well as that one? I will have to run the solder over the two tracks. Okay, so I'm going to show you how it's done. As you can see, the second track rests on top of the first longer track here. So I'm going to introduce a bit of solder where one edge of the second copper track is over the first copper track. You can see now that there is an overlap because the solder connects both tracks together now. So I'm going to pause here and repeat for this point. So this is the first one, second one, third, fourth, fifth, and sixth. So when you solder your membrane switch circuitry over here, make sure you do the same. Alright? A commonly made mistake by students would be they actually place a bit of the solder just on top of one track. You should actually let the solder flow over to the second track. Alright? If you are unsure, you can actually, like for this example, introduce some solder over here and down here as well. Alright? This ensures that there's a complete connection between the two tracks. So I'm going to rectify this problem here because there is no connection at this point. So sometimes students, when you test your circuitry, it doesn't light up. First troubleshooting skill step will be to check the connection on your copper tracks. Alright, I've actually ensured that the solder flows over both tracks here, one and here one. So now it leaves for me to get a 9-volt cell, plug it in, and do a quick testing of the LED whether it lights up. Alright, I found a 9-volt cell and I've already attached it to the clip here. So I'm going to rest this and do a quick test and see if the green LED lights up. Here goes. Alright, so your circuit works. So now it leaves for me to either use glue stick or double-sided tape and paste it over the outline here, like so. Or if you don't have glue stick or double-sided tape, what you can use is also Scotch tape. But please remember, don't tape the Scotch tape all across like that, alright? Because there will no longer be any conduction here. So if you want, you can use a small strip of Scotch tape over here as well as over here. That will be enough. I'll pause here for now. So for me, I've used 4 strips of double-sided tape. So I'm going to peel the protective paper and I'm going to paste it over. Alright, after pasting this, you test your circuitry again to see whether it works. It works. This concludes the performance task for you. Please do refer to page 17 of your D&T journal for the level marks awarded for the based on the assessment rubrics for your performance task. However, you are encouraged to consider how you can place your membrane switch circuitry so that you can correctly position, for example, a LED over here, just very briefly, so it lights up, you know, and brightens the day when you place your handphone there. And in another example, you can find appropriate positions where you can actually drill a hole like so, and your LED will light up in that sense, okay, when you press on the membrane switch. So that concludes this video.